I'm ARVIN Enriquez, your subject teacher. For this video lesson, we're going to solve random math problem from your Maxima and Minima under your differential calculus. So for this problem, given the cost equation of a certain product as follows. So here there's a given cost equation with respect to your t or your time. So your C now is equal to your P t square minus your 200t plus 10,000, where t is in years. So meaning to say this t is in terms of years. So we're asked to find the maximum cost from the year 1995 to 2002. So for the solution for this problem, we're going to use the given cost equation, and we're asked to find the maximum cost from the year 1995 to 2002. So first thing to do, we need to get the derivative of this given uh, cost equation for us to get the value of t. Now, let's take the derivative of this cost equation. So the derivative of c now with respect to t, since there's a given cost equation here, which is your c, that will be equal to a value with respect to your t. Now, in getting the derivative of the given cost equation, so we just simply take the derivative first of your c, which is your dc over dt. So that will be the derivative of c with respect to t. Now, what will be the derivative of your 50t squared? So we just simply multiply this exponent 2 to your numerical coefficient here under your first term, which is 50. So 50 multiplied by 2, so that will be 100. And we subtract 1 to your exponent, that will be equal to t now. So therefore, the derivative of your 50t squared is 100t. Next, for the second term, so what will be the derivative of your negative 200t? So in reality, there's an exponent here which is equal to 1 in your variable t. Now, we just simply multiply this exponent 1 to your numerical coefficient under your second term, which is 200t. So 200 multiplied by 1, that will be 200. So we need to subtract 1 to your exponent. So that will be 1 minus 1. So t raised to 0. So that will be equal to 1. So if we multiply 1 to 200, so that will be equal to 200. So therefore, the derivative of 200t is equal to 200. Now, for the third term, so what will be the derivative of your third term, which is 10,000? Since we all know that the derivative of a constant is equal to 0. So therefore, the derivative of this c, with respect to your t is equal to 100t minus 200, and we're going to assume that this will be equal to 0. So here, there's an equation that we can use for us to get the value of your t. For the next equation, upon simplifying, this 100t minus 200 is equal to 0. So we can neglect this part, your dc over dt here, because there's an assumption here that we assume that this equation is equal now to 0. Then we transfer this negative 2 to another side of your equation, from negative to positive. That's why it's positive 200 here. Then from 100t here, so the operation between your 100 and t is multiplication. Once we transfer this numerical coefficient from your 100t, no, from multiplication going to another side of your equation, so the operation will change. That will be division now. So for us to simplify, no, your t now is equal to 200 over 100. Or simply, for example, if this is your given equation, 100t minus 200 is equal to 0, we transfer this 200 to another side of your equation, so that will be equal to positive. So we change the sign from negative to positive, and we divide both sides of your equation by 100 for us to cancel, no? Cancel out the numerical coefficient under your t, and for us to have only your variable t in your left side of your equation, so that will be equal to 200 over 100. Now, if we try to simplify this one, we all know, no, from our algebra, no, if we divide 200 by 100, so that will be equal to 2. So since it was being mentioned in our problem, no, that your t is in terms of years, that's why your t now is equal to 2 years. And we're asked to find the maximum cost from the year 1995 to 2002. So since the computed t here is equal to 2 years, so from 1995, since we're asked to find the maximum cost from 1995 to 2002, so we just simply add these 2 years to your 1995. That's why in getting or in finding the maximum cost from the year 1995 to 2002, we just simply computing for the value of your maximum cost that will occur in the year 1997. Because we just simply add this computed t in your given year from 1995, no? Since we start the problem, no? So there's a given value of your years now from 1995 to 2002. So we start from 1995, and approximately uh, we end up, no, with your 2002. Since our computed value for your t is 2 years, we just simply add these 2 years to your 1995. So the maximum cost that will occur, no, in between your 1995 to 2002 will fall on 1997. So what will be the maximum cost that will occur in the year 1997? So we just simply use the given cost equation in your problem, no? And we just simply substitute the value or the computed t here as the value of your t in your given cost equation. So for the maximum cost here, no, so that will be 50. So we just simply use this given equation, no, of your cost equation. So 50, we substitute the given or the computed t, no, which is your 2 years. So we substitute 2 as a value of your t square minus 200 multiplied by t, that which is equal to 2 plus 10,000. So there are times that we neglect this 10,000, no? So that's an error. So we should use the entire equation, or I mean the given equation, no? So we just simply assume that this 10,000 is equal to 0 if we take the derivative. So we just simply dealing with that concept, no? Once we're asked to find the value of the derivative of the cost equation, for us to find the value of your t in terms of year, for us to have a numerical value for your t. Now, in simplifying, no, with these values, so the maximum cost now is equal to 9,800. So since 50 multiplied by 2 squared, so 2 squared is equal to 4. So that will be equal to 200. 200 minus 200 multiplied by 2, that will be equal to 400. So plus 10,000, so that will be equal to 9,800 pesos. Meaning to say, the maximum cost that we can meet from 1995 to 2002 is equal to 9,800. That will fall in the year 1997 based on the computed T here from the derivative of the given cost equation. So thanks for watching. If you want to like, comment, share, and subscribe, so please do so. Again, thank you. I'm ARVIN Enriquez, your subject teacher for differential calculus.